Hi. So for Code Lab's summer 2020, our project was COVIZ-19. My name is Saitheeraj. I'm a rising junior at the University of Tennessee, Knoxville, and I'm studying computer science and math.
Hi, my name is Gandhar Viragi. I'm a rising senior in high school located in Maryland, and I plan on majoring in CS in college.
Hello, my name is Rakil Ahmed. I'm a rising junior at Hunter College. I'm studying computer science.
And our mentor was Mr. Yang Xu, and he's a software engineer at LexisNexis Risk Solutions. So for our original problem, the original scope of it was to create a REST API for some COVID-19 data that we received as a CSV file. And then we also had to create an application that could call this API and effectively use it, and to calculate a max death rate based on the data we had within that CSV file.
Because we finished the original scope of our project pretty early on, we decided to extend our project. And so we added more data to our API, and we also decided to create a front-end dashboard, so effectively doing full stack.
And we used MongoDB as our database, where we save all the data from the CSV file. And we used to save the data on the database, we used REST API created using Node.js and Express.
And so we built a Java application as well that would call this API. It had included multi-threading, caching, and logging. And we also added data as part of the extension from our project from this Johns Hopkins repo that included daily updated COVID-19 incident reports and info to our API.
We created our front-end user dashboard in React.js, and we hosted our REST API and dashboard on Heroku and Vercel, respectively. All right, so here we have our data shown in the browser. This is our whole database for our COVID-19 data given by our mentor. So you see all the metadata like the ID, ISO code, the continent, location ID, the country, and really for our project, the only pertinent ones are the location ID and the location. The location ID just refers to the country. So if we go into a specific route, here we're using 5. So in the URL /5 just refers to location ID 5, that's a parameter. So here you can see all the countries with location ID of 5, which refers to Angola. And so if we go to our server side, this is our REST API. We have our server.js. This connects to our Mongoose. We're using Mongoose. It connects to our MongoDB database, and it also has CORS, which is for our front-end permissions. And yeah, this is just basically connecting to our Mongoose. In our data.js, we have our schema, which is just outlining how the data looks for each entry in our database. And our data.js /API shows all of our data, and on our /API/ID, our ID is the parameter, which you can put in on the URL in our localhost, which we showed before. And that's just querying the data for the location ID.
And so the second part of the original scope of our project was to build an application that could successfully call this API and calculate some statistic from it. In our case, we wanted to calculate the max death rate. And since our total cases and total deaths were cumulative, we just had to find the max total deaths and total cases, and we just had to divide them, and that would give us the max death rate for each country. And so within our code, we also had caching, so we wouldn't have to repeatedly call the API. We also had multi-threading, so we could call the API in parallel or check the cache in parallel. And we had a time delay just so it gives it enough time to actually check the cache if it was calling the same country, it was calling a country it's called before. And in our thread logger, we use a singleton pattern. So each thread would only log the output one by one and not just all at once. And And then in our thread runner, this is just our overall thread class. We can see just it instantiates the threads, has a whole run and start methods, and it also will, yeah, it will call the API and check the cache as necessary. And if we look here in the output, we can see it instantiating the cache, creating all the threads, calling the API here, determining the max death rate. And as you go, you'll also see cases where it will, like right here, where it checked from the cache.
So our architecture is pretty straightforward. Our MongoDB is hosted on Mongo Atlas, and we're using Python to parse through the Johns Hopkins data repo that we downloaded. Our REST API is deployed in Heroku, and we're just changing endpoints to display different things. And our React web application is deployed in Vercel, and that calls our REST API.
To visualize the data, we decided to make this front end part of it. Here, as you can see, we have tabs, total cases, total recovered, total, it's dynamic as well, total deaths. It's dynamic as well, it's also showing up on map. Here, as you can see, the tables where the user can go through by countries. And also we have charts, dynamic charts, and also we have tables for states. And also we created a news tab where the user can get the latest data of COVID-19. And here it's just Twitter accounts for CDC and COVID-19 tracking account. It just tracks all the COVID-19 stuff. And we also added a user dashboard.
Yeah. And on this user dashboard, lets people submit like their name, a location, and just like a short message just to share with other people that are logged on to the website or just using the website, like what information they had. So like you can see here some messages, and you can see Gandhar like typing in message live and submitting it. You can see like the dynamic response and where it changes. And yeah, you can look at all these other responses which we submitted just as a test. And yeah, so like this lets users just interact with our dashboard more dynamically.
We are also planning on adding user authentication on our user dashboard. So where the user can talk, interact, chat, and also submit data if possible. We are also planning on adding a button where by the submit section where it says upload CSV, where the user, if they have validated information and they want to share, they can submit the data as well. And we can use that on our main database to show visualize all the data on our home here.
Another idea that I wanted to implement because I'm a high school student is extending this project to show SAT and ACT location shutdowns due to the coronavirus. Because a lot of schools that host the SAT and ACT tests don't communicate with the institutions, students don't necessarily know if their test location for their SAT or ACT is going to be shut down, and there's sort of a miscommunication. And so if there could be sort of a peer-to-peer network where people can say, hey, at this test location in this state, this country is shut down, people get like more information regarding their test sites.
And also, since I personally have an interest and background in like machine learning and modeling, I thought it'd be kind of cool to maybe add a feature where we either have pre-made models already on our website, or like epidemiological models, more dynamic models that just have some predictions about future instance rates or projections, or we can let maybe users upload their own models or like their own data to visualize against it, and like their own models to kind of do projections as well. Of course, that require more investigation and looking into it. And we also thought about potentially adding more data sources to our API, not just the Johns Hopkins one, or maybe even using a third-party API that already exists out there that's already more mature than the API that we have, so we don't reinvent the wheel and we can focus more on our web application instead of just developing or just basically mimicking what's already out there. And so this slide right here, this future slide, is just kind of summarizing what we talked about earlier when we were showing our web application, when we were like talking about where we wanted to turn it to React Native app, where we wanted to add the authentication and do the modeling. and show the test location. And so, yeah, we definitely have plans for this application in the future. We definitely want to keep working on and keep contributing to it. Okay. So in this project, we learned a lot. We learned a lot of different things, but one of the big things we learned was about collaborating on like about a month longish project. And for most of us, this was like our first time working together, or working as part of a team on like a long enough project like this, like a software project, and not in a school setting. And we learned a lot of different things, just like communicating as a team, just allocating tasks, like which tasks would be like can be most efficiently allocated to get the most things done. We also learned how to like bounce ideas off each other and kind of determine which ideas were the most feasible. We also learned how to use Git and GitHub collaboratively and as a team, like with branching and merging a pull request. And we also learned kind of what it's like to have a manager or supervisor with our mentor, Yang Shu, and just getting advice from them, but like not being spoon fed or just not being handed the cone, just having someone help guide and give us like overarching goals and like in direction which we want to take the project in.
And obviously, we also learn full stack development. And in this case, it was Marin stack. So like building the APIs, using Java as a quick way to test our APIs, querying it, and also using front end or React.js to visualize the API data and sort of give an interaction for the user.
We deployed our API to Heroku and our front end React.js application on Vercel. And we also learned about multi-threading, caching, logging, and how to use all of them together in a program to make the user's experience effective.
And to conclude, here's our contact info. If you have any questions or comments, you can email us or link up with us on LinkedIn. And that's about it. Bye.